All right, welcome to Code Corner. This is a video series we do at Mayfield Renewables where we talk about codes and standards as they relate to the solar and solar plus storage industries. And today I'm going to focus in on the 2023 NFPA 70B, and 70B is the standard for electrical equipment maintenance. And in 2023, solar and PV systems specifically were added to 70B, and so it's brand new for the standard to have PV systems in there. And the thing I'm going to talk about here today is installation resistance testing. And so first off, let's talk about Chapter 30 in 70B. This is where you're going to see the table for our requirements, or what they're going to lay out, the PV system electrical tests that they have there. And so you can see today what we're going to be looking at, PV strings and modules and this installation resistance. So in the table, they've listed out different tasks, different test types, and different notes on those. And so that's what we're going to be focusing in on for this conversation that we're having here today. So multiple tests that you have to do, so we can talk about those in future code corners as well. So installation resistance testing. So hopefully high level, quickly what it means. And kind of how we're accomplishing this. And so in short, what you're trying to do with an installation resistance test is you're trying to pressurize the conductors and you're looking for any leaks. So just like water in a pipe, so we always have that water in the pipe analogy for electricity. So if you have water flowing through the pipe, if you have a damaged pipe, then it's going to spring a leak. Very similar, if you have conductor and you have insulation over that conductor, if that insulation gets damaged, you're going to spring a leak of electrons, if you will. So, definitely don't want to be having that. And so it leads to faults, leads to potential problems, fires, things like that. So we want to test the conductors and try and identify any problems early on. So an insulation resistance tester will go ahead and it will inject voltage into your conductor. And so you see on the left-hand side, we have an illustration where we have the tester connected to the positive conductor. In this case, just the positive home run is being tested itself. And so you can disconnect that. And what's going to end up happening is that tester is going to inject that conductor with voltage. It's going to pressurize it and put a higher than normal voltage on it. So depending on the tester you have, it could be anywhere from 500 to 2.5 kV. So 500 volts all the way up to 2,500 volts. They make insulation resistance testers that get larger. The handheld versions, the largest you're going to see probably is 2.5 kV. So for our systems that we're installing now, that's going to be really the upper limits of what we need to do. One note I'll put out there is IEC 62446 is an international standard on commissioning and testing of PV systems. So that gets into this as well. So encourage you to take a look at that. But you'll get some values there. And so really what we're trying to do is we're injecting that voltage. A minuscule amount of current is able to flow through. And the tester will then look for any return current on ground. And so if you have any amount of current coming back on ground, it will register that. And the meter itself will tell you what the resistance is in ohms. And so it's doing a calculation in the meter itself. And so you have a known voltage, you have a known current, and so it can calculate what that resistance is. And so if you get a reading back that's a very large resistance, that tells you that your conductor is in really good shape. If you get a resistance that comes back very, very low, then you know that you potentially have problems in that conductor, and maybe you need to replace that conductor, or investigate it some more. So it's a pretty involved test and something need a fair amount of training on. So I recommend looking into that some more. But that's at a high level what it is that you're trying to accomplish with these tests. And then the other thing I'd throw out there is some of these handheld meters will have what's called a guard terminal. And so this is a really interesting phenomenon. So if you can imagine, you're injecting that conductor with high voltage, and no insulation is perfect. There's no way for any insulation to be absolutely perfect. And so some amount of current will leak through and come out, and will actually, depending on how dirty the conductors are or the environment that you're testing in, there is the ability for actually the current to come back on the surface of the conductor. If it's wet or if it's oily or if it's dirty, it can actually return back on the surface. And the tools that have this guard terminal are able to account for that, register that, and use that in the calculations and tell you what the true resistance of the conductor is. And so in brand new installations, you should be seeing very, very large resistance values. Over time, when you're maintaining systems and you're running these tests over and over again on an annual basis, you may see some degradation of those conductors, and using something like a guard terminal will help identify if it's really the insulation that's poor, or if there's just a lot of dirt and buildup on those conductors. So something, again, additional training, additional requirements on understanding exactly how those work, but they're pretty interesting tools and that are able to do that. So highly encourage you to take a look at those. And as we saw in 70B, this is one of the requirements or one of the tests that they put out there. So real quick, this is meant to be a high-level overview for insulation resistance testing. This is not meant to be the only training that you get by any means. But in this slide, we have a few images of doing some tests and at PV sites, and being able to see. Hopefully, you can see it there on the screen if your screen's not too small. But we have we're doing 3 different tests and we're getting 3 different readings on that. And so on the far left test, we have a reading, we're getting over 200 gigaohms. So that's, we've actually, you can see it just says greater than 200 gigaohms. That specific meter, that's the highest it can read. So we've pegged that meter out. So we don't even know what the actual resistance is. It's a very, very large value. The next one over in the middle there, you see 16.3. And that is a relatively low, if that's mega ohms or kilo ohms, I forget because I can't see that screen very well. So, but nonetheless, it's lower. And then on the far right, you see 0.1. So all of these readings should mean something to you when you've gone through the proper training and understand what you're looking at. These will all mean something, in terms of the relative health of those conductors. And so that, the one in the middle would be the biggest, one to take pause and look at and say, there might be something wrong here. There might not be, depending on the exact voltage you're using, what that reading is coming back at, and what the allowances are. So the other 2 on the bookends, though, greater than 200 gigaohms, that's a lot. That's a huge resistance. And then 0.1 kilo ohms, that means there's essentially no resistance, and so there's a problem in that one. So again, understanding the meters is important, but these are just different readings that you may see, types of readings that you may see out in the field. And so all of the images that we just were showing in that, and those illustrations, this is a project that we've been working on with Megger. So Mayfield Renewables and Megger, we've been working together to put this electrical testing standards guide together. And so on the screen there, you can see a location where you can go download the chapters that have been written for this testing standards guide. And so what it's trying to do is put the information in the hands of the technicians, so you understand the hows, the whys, of the tests, and understand what the results are, and be able to better maintain and operate PV systems out there. And then for ourselves, Mayfield Renewables, we have workshops available. So if you're interested in this or other topics, we have both pre-recorded and live courses that we offer to our clients. So if that's of interest to you, feel free to reach out to us at mayfield.energy. And we have some of our courses on our website, so you can take them right there, or talk to us about doing live courses. And if you always want to hear from you, so if there's another topic or another Code Corner topic you'd like to talk about, or if you have questions on this one, our contact information is here. So would love to talk to you. So feel free to reach out.